Hello, folks. Here we have our last installment of notes for engine parts. So the first part we're going to look at is the oil dipper slash governor. This is usually a combined piece. The one that's right up here, it's white with the kind of silver pieces on it. This piece usually hangs off the side of the camshaft inside the crankcase. And basically what it does, it has some gear teeth on it, and the gearing is either going to run off of the camshaft gear or it's going to run off of the timing gear on the crankshaft. And it's directly tied into the engine speed. So essentially, as the engine speeds up, this gear will turn faster. On the top of this white gear, you'll see two metal silver pieces, and there's another white plastic piece in the middle. This is actually a little button, and the silver pieces are called flyweights. Basically, the faster that the white piece spins because of the gearing, the further out that the flyweights will go. And what they do is they actually kind of push up on that plastic piece in the center. That plastic piece in the center is tied to our governor arm on the outside of the engine, and that governor arm is tied directly back to the carburetor. Essentially, what's happening then is as this piece speeds up and the flyweights push out and the button pushes up, it actually closes down the carburetor and lets less fuel in. This effectively slows the engine back down and will also slow this gearing down eventually, right? There's a slight delay, obviously, but the engine will slow down. That means that the crankshaft will slow, and eventually this will slow down, and then the flyweights will actually come back in, and that button will move down again, and then this will have the opposite effect on the outside of the engine. Essentially, this will open the carburetor back up, allowing more fuel to come in, and the engine will speed up again. Essentially, what this does is it creates a little bit of a wave like this if we think about speeding up and then slowing down. And really what this does is it governs the speed, meaning that it tries to keep the speed of the engine as even as possible throughout use. So as you hit a wet patch of grass and the engine all of a sudden slows way down, this is going to open the carburetor back up and introduce more fuel. If you hit an area where there's no grass and the engine starts running too fast, then this, again, will have the opposite effect, slow the engine back down by reducing the amount of fuel. Okay, so that's its primary function. The secondary function is that it also is going to pick up oil that's in the crankcase and just kind of throw it around the engine and coat all of the internal parts so that nothing overheats. These little pieces that kind of stick off the edge, those are the oil slinger pieces. And again, they just kind of, as it's spinning, they dip down into the oil and they just kind of fling it throughout the engine case, and everything is just kind of randomly coated. Some engines actually feature a specific oil dipper. It's connected to the bottom of the connecting rod. There's a couple different shapes that you can see in the lower picture here. And again, it basically has the same effect. It's just going to dip into the bottom of the crankcase as it rotates, and it's going to pick up some oil, and it's going to kind of fling it up into the air and spread it throughout the engine and crankcase. Okay. So on the top right here, we have our magneto. This is one of the electrical components on our engine. Its primary job is to create spark for the engine, or create the electricity that will then flow through the spark plug that creates the spark. The magneto basically is a coil of wire. Inside the black area here is actually a coil, and really the outside metal piece here is split into two parts. And basically, as the flywheel turns past the magneto here, the magnet that is embedded into the flywheel is actually going to create an electrical current. So as the magnet passes through one side and then quickly the other, the opposite polarity, magnets have both a positive and a negative side on them. So as the positive and negative side flow past the magneto here, they're actually going to create current or flow of electricity. All right, that flow is going to then travel through the wire here, and then it's going to go into the spark plug. Now, remember that there's only one spot on the flywheel that has the magnet, so that means only once in a revolution will we actually get spark, okay, or will we get that. And this is one of the major reasons. You can see down on the bottom here, hard to see, but we actually have a flywheel key here. And that flywheel key is made so that the flywheel will stay in the correct position on the crankshaft. Okay, and this has to do with engine timing. If the flywheel is sheared, meaning that it's broken or the flywheel has twisted on the crankshaft, then the timing will be off and the firing of the spark plug will not be in sync with the piston. And this is going to cause either power loss or a very noticeable noise or shake in the engine because the timing is going to be off, and that eventually can cause some pretty major problems. Okay. The magneto also does have a grounding wire. You can see this little wire over here. You might have plucked one off of yours. Usually there's a little metal tang up here where it connects to, and then the wire is going to go back somewhere onto the metal case on the outside of the engine. And this is actually used to stop the engine, believe it or not. So basically, let's say you're mowing the lawn and you grabbed onto the front of the lawnmower handle and you're going. As you hold down that handle piece, it basically has opened up a little metal switch, okay, somewhere on the engine that's connected to this grounding wire. When you let go of the handle, the switch then connects, and the electricity that was being generated and pushed through the spark plug wire here now instead will be pushed through the other wire here and then goes to a ground spot on the engine. Basically, no more spark means the engine can't ignite the fuel and it will stop running. Okay, so if for some reason the engine won't turn off, it probably means that you're not getting a good ground or this wire is broken. But that's most of how most modern engines turn themselves off, is by grounding out and stopping the flow of electricity so that the engine will stop pretty quickly. Okay. All right, last little piece here. Some of you may have these two bottom pieces. This would be more common on a larger engine, so an engine that probably came off of a riding lawnmower or a large snowblower or something bigger like that, quad or motorcycle as well. Okay, so the square piece up here is known as a regulator or rectifier. Okay, and the other circular piece here is what's known as a stator. Basically, the stator is like a small little generator. You usually find this on the inside, under the flywheel. So on the inside of the flywheel, some engines will have a second set of magnets. And basically, as that is turning, just like with the magneto, it's creating power. You can see there's a lot more spots on this one. So it's creating power pretty much the whole time. Okay. Except this power is actually going to some other output on the engine. This would be used to charge a battery, okay, on a tractor or a mower, something like that, right? We use the battery to start it, but we want to charge the battery back up. It would also be used to run things like lights on your tractor, maybe a horn, okay? If it's a bigger machine like a Kubota or something like that, it might be used to, run blinkers and hazard lights and other things like that. So anything that's electrical, okay? And again, charging a battery would be a big primary function of it. The regulator here takes the power from this coil, and it basically just makes sure that we get a nice consistent power output. If you think about the fact that your engine revs up and down as we go and changes speed, that means that the speed at which the flywheel turns around the stator would also change. So if you think about the electrical output that we would be getting, we'd be going up and down with the engine, which could be kind of bad for some of our electrical components. That means the lights would feel like they're flickering, they'd get bright and dull, okay, which they might work, but it could also cause us to burn things out or over-energize a circuit, which could blow the circuit. So the rectifier takes this wave that's coming in, and it basically just gives us a nice flat output of 12 volts all the time so that we can get some nice consistent power going to the electrical pieces on our engine and not ruin them. And not ruin our batteries, and again, just make sure that we're getting a nice consistent charge so that things are working. So if you have an instance where, say, the battery is not charging, it could be that this regulator is gone or no good anymore, you have a loose wire, or that there's something wrong with the stator as well. Sorry. Again, the flywheel area is certainly a spot where mice and things like that like to make nests over the winter. So come spring, you might want to check if there's a lot of junk behind there. You may want to clean that out because it could be blocking something that's stopping the power from being made.